So last class we discussed about pressure. We said pressure is the ratio of force upon area. What area? The area of the surface on which is acting. So if the pressure was acting on a simple rectangle, well, it's the area of the rectangle, and make sure that the force is always perpendicular. At grade 8 level, the forces are always perpendicular, and such perpendicular forces are called thrust. The new unit of force is Newton, the unit of area is meter square. So the pressure's unit is Newton per meter square, which is also known as Pascal. 1 Pascal is said to be the pressure exerted on a surface of 1 meter square when a force of 1 Newton acts vertically on it, or normally on it, or perpendicularly on it. Have you understood? Now, though you don't get numericals in this grade 8, but let us try and see one numerical. Okay, how nice. And we saw many cases. What all cases we saw? We saw that if we keep the pressure force constant and we vary the area, the pressure varies inversely. Means if you increase the area, the pressure will decrease. If you reduce the area, the pressure increases. Then we saw another case where we increase the force and we kept the area constant. In that case, the pressure used to increase with the increase in force, right? Fine. So let's see one small numerical, and then we proceed ahead. That would conclude our discussion of force for solids, and then we will migrate for discussion of force for liquids as well as for gases. Okay, so we take back our same example. So we make our cuboid, the cuboid that we had. Okay, and now we will add some dimensions to this cuboid. So let's add some dimensions and do one calculation. Okay, so this is my cuboid. The easiest way to make cuboid is rectangle on rectangle, and then join the edges. Okay, so I need to add some length, breadth, and height. So what I do, I don't write length, breadth, and height. I'm just writing that, this surface is, say, 5 meters. Fine, children. This surface is 4 meters, and this is 3 meters. Have you understood? Okay, right. So we'll see 3 scenarios out here. Okay, 3 scenarios. So what are the 3 scenarios? Let's say, so that your concept becomes clear. On our first scenario, 3 scenarios. Hang on, children. Let me make it a little bit more beautiful. Let me make it more beautiful. I'll take it here. Okay. This is case 1. Okay. And you just enjoy. We could have. Right. And what isn't it? How did it take the copy? I've forgotten. The other software I knew. Copy. So, yeah. Copy. Yeah, copy. And then there should be a paste also, right? Copy it has taken. And then, okay. Yes, got it. Right. So here what we are doing is this. Okay, fine. Now, just enjoy it. Enjoy. So we would fine. So first we kept it on the base on the 5 meter. Then on the next one, we are keeping on the 4 meter. And on the third example, let's say we are keeping it on the, we're keeping it on the 3 meter. Okay. So we'll just change our dimensions so that they appear straight to you. You don't get confused. Okay. Hope you are able to understand what I'm trying to do here. Okay. Right. Chalo. This was 5 meter. This time I have rested it on the 4 meter. This is the 3 meter. And this is my 5 meter. I don't know. Why does it not go away? Okay. This is my 5 meter, children. Understood? And now I have rested it on the 3 meters. And this is my 4 meters. 3 meters. No, not 4 meter. Let's say this is my 5 meter. So let's say this is the 5 meter, and this is 4 meter now. So I've turned it on 3 different sides. Have you tried to understand what I'm doing? Right? The shape should have been different. You want me to redraw and make the shape because you're seeing 5 meter very small. Is it okay with you? Means we have taken the same cuboid. This was a cuboid. In this case, we have made it like this. Have you understood? And on the third case, we have kept it like this. Once it was on its flat base, once it was on its short base, and once it was like this. Have you understood? So we'll go by our same example. So our example is like this. Let's see what is the implication of pressure now. So let's put it a little bit down. And similarly, let's take this one too and bring it a little bit. Okay. And let's take this and bring it. There are 50 different things to distract you. Okay, right. So let's now put our force. So there's our force. First time the force is acting on this surface. Now the force is acting on this surface. And now the force is acting on this surface. Okay, understood? So let's take a value for the force. So how much do we take? Let's say the force every time is say 10 Newton. Please, right? The force is equal to 10 Newton. And the force is equal to 10 Newton. And we will see that for each of the 3 cases, how much is the pressure. समझ में आया? ये आपको बड़ा interesting चीज दे रहा है. Suppose you take a brick and you exert the same force on the brick, the pressure can be different based on how you orient the brick. Have you understood? This is a very nice example. The same, have we changed the solid in any case? No. Have we changed the force? No. But the pressure will come different. Okay, let's calculate the pressure for the first case. Okay, the pressure for the first case, the pressure P1 would be given by the force, right? How much is the force? 10 Newton. Acting upon a surface area of how much? This is 5, this is 3. So this was 5. So it should be 5 meters into 3 meters, which is equal to how much? 10 by 15 Pascal. Newton per meter square is known as Pascal, right? Are we fine? Newton per meter square is known as Pascal. Or if you are not familiar, then we can do like this. We can put a Newton per meter square here, and then we can again write 10 upon 15. How much? Pascal. Clear? Okay, let's see the second case. P2. P2 as a pressure would be the same 10 Newton. Now by the qualifying area, how much is the qualifying area? 4 meters multiplied by 3 meters. Did you understand? 4 meters multiplied by 3 meters. Okay, so 4 meters into 3 meters, which is 10 Newton upon 12 meters square. Hey, whoever is sharpening pencil, make sure you don't, anybody, oh no, sharpening pencil. When someone sharpens pencil, my heart cracks. That means the sheds will be all on the floor. Okay, have you understood? So in this case, how much was the area? 15 meters square. In this case, how much is the area? 12 meters square. So obviously the pressure here would be more because we are reducing the area. And then we'll compare everything. It will be a good rational number exercise also. So 10 and 12. So this is 10 upon 12. How much? Pascal. Fine. And let's see the third pressure. P3. P3 is 10 Newton divided by, what is the qualifying area now? 3 and 5. So this is my 3 meters and this is 5 meters. So 3 meters into 5 meters, which is equal to, why did we get 3 and 5? Same, no, it should not be. So yeah, it should be 4 and 5. Yeah, it should be 4 and 5. Very good. Good. Okay, koi baat nahi. We'll make it 4, 5, and let's make this as 3 meters. That's all fine. 4 meters. Okay. So it should be how much? It should be good. Very good. I'm happy. 10 Newton divided by 4 meters into 5 meters, which is equal to 10 Newton by how much? 20 meters square, the maximum area. So this is 10 by 20. How much? Pascal. So we now need to compare everything and see, right? And we need to find it out mathematically also, which is the greatest. Now these are all in rational numbers. So how do we find out greatest? Little bit of maths we kar lete hain. Let's reduce this to the shortest, lowest terms. Tell me, Rayan, how much is it? Very good. 2 by 3 Pascal. How much is this?
5 by 6.
5 by 6 to 5 by 6 Pascal. And how much is this? 1 by 2 Pascal. Now we need to, this you will also find in your mathematics. Like if 3 rational numbers are given, we need to now find who is bigger and who is smaller. What are the 3 numbers? Tell me. 2 by 3? You remember? You remember them? Okay. We need to compare between 2 by 3 and 5 by 6 and 1 by 2. So see, we are again revisiting rational numbers. So just look at it. Are they like fractions?
No.
No, they are not like fractions. Like fractions होने से सबके denominator same होता था, है ना? So let's do it like this. Between 2 and 6, can 2 kill 6? Yes. So who is the LCM? 6. Between 6 and 3, 6 is the LCM. So 6 is the boss, right? So we make everyone 6. 2 upon 2, it becomes how much? 4 upon 6. 1 upon 1, it becomes how much? 5 upon 6. And this should be how much? 3 by 3 becomes 3 upon 6. So who is, in which case are you finding the maximum value? 5 by 6. So we will write 5 by 6 is the maximum, followed by 2 by 3. 2 by 3. Followed by 1 by 2. Yeah, because these were our original entries, right? Can you now look into your book and tell me which one was P1, which one was P2, if anybody had copied? 5 by 6 was P2, okay?
2 by 3 was P1.
P1.
1 by 3 was P3.
P3. That means P2 pressure has come maximum, right? That means P2's area should have been the minimum. Look at P2's area, 12 meters square, minimum area. 15 meters square, 20 meters square. Which pressure came the least? Which is the least pressure? P3. That means P3's area should be maximum. Let's go back and see P3. P3's area is maximum. Clear funda pressure leke. Ye wahi lohe, but it was the same wooden block. We changed its orientation into for the same load. On the same wooden block, the same service is standing. But we once twisted it on this side, once on this side. Share samajh mein aaya? Load does not change. What changed? Surface area changed. And once surface area changed, it directly impacted the pressure. Clear now? This concludes pressure for solids in your case. So questions that you will get in your school: why do school bags have broader strap? Why is it easy to cut with a sharper knife? Why should you use a sharper needle for a injection? Why are tractor tires wider? Why does a gardener squeeze the pipe end while watering plants that are far away? I hope you have got the clarity or idea. I had actually written for one more book called the Exam Idea book. If you have taken the Exam Idea book, that will also be very helpful. XAM. The same publication. This is a grade 12 book, but it will be, it was there. Exam Idea. Yeah, that's one, that book. Exam Idea. Exam series. That is very good for your unit tests and all. Yeah, this is very good for your, this is excellent for your unit tests and all. Maximum questions come from there. And don't too much blubber about it in your school. Top level. Okay, all questions come from there. Fine then, children. Shall we move ahead? So we go for now liquid pressure. Pressure exerted by liquid. Now from here, discussions become even more interesting. Pressure exerted by liquids. Exerted by liquid. So only two important things we need to study here. Liquids exert pressure in all direction. Liquids exert pressure in all directions. Okay. Liquids exert pressure in all direction means what? Say suppose there is a water pipeline which is there on the road, so beside the road on which you are actually walking. And the water pipeline has got a joint, means we have a flange joint out here. What do we call it? A flange. flange joint. Flange means, you know, like two faces joined together with bolts. Water pipes are joined in that manner. Now you will see if some leakage has happened, the water will actually leak out like a fountain from any of the side. It's not that the water only leaks out from top. If the leakage is at the bottom, you will find the water is leaking out in this manner. And if you go and like a naughty child, little bit of leakages on all sides, you will see that the water is coming out radially from all sides, which shows that liquid exerts pressure in all directions. Have you nowadays you don't get that, but when we were kiddos, we used to get water balloons for playing. So the balloons used to have water inside them, and if you start making small holes like for a rubber thing and start squeezing it, the water will be ejecting with pressure equally on all sides. So always remember, liquids exert pressure in all directions. Okay, this is something that you should remember. Liquids exert pressure in all directions. And one of the example for this is when you see a leaking pipeline, the water comes out, is sprinkled out in all directions. It's not that the water, see, generally when we have a leakage, the water also drips down from the bottom, right? Here it's pressurized. The water is pressurized. Water is flowing at a pressure. And if the leakage comes out, it will just come out radially from that surface. Have you understood? It will just come out radially. So liquids exert pressure in all direction. The other thing, this is one thing which you should know at this grade. The other thing we will see is, say suppose I have a container. This is a container, right? And I have filled this container with liquid. Try to understand here. I have filled this container with liquid. And let this be water. I have filled it with water. Right. Now, what is my interest? My interest is to find out that what is the pressure at this surface? What is the pressure at this level? What is the pressure at this level? And say what is the pressure at this level. Now from here, please pay attention, okay? We want to find out what is the pressure at each level. So you've taken a drum in your house or a bucket and you have filled the bucket, right? The first level at which you are interested, children, the first level at which you are interested, this is my level 1, which is the surface. Okay. What contributes to pressure? There should be an area and there should be a force. Now at the top surface, is there any liquid right at the top surface? No, there's no liquid beyond the top surface, but there is something. What is there? The atmosphere is there. So at this surface, the pressure you will sense is only the atmospheric pressure. What pressure will you sense? Only the atmospheric pressure, because there is no liquid contributing to any force, right? So here I'm going to, and we will read about atmospheric pressure later. So here what I'm going to sense is only atmospheric pressure. Is this understood by you? And I'm denoting it by PA. Atmospheric pressure is acting on it. Every layer will get the impact of atmospheric pressure. Are you understanding? It's like a lift cart. On top of the lift cart, one monkey is sitting. That is the atmospheric pressure. No matter wherever you go, that weight will always be acting on you. So atmospheric pressure is here also. Atmospheric pressure will be here also. Atmospheric pressure will be here also. No doubt about that. Since atmospheric pressure is everywhere, I am not considering it because it's not going to change my calculation. Are you understanding? Atmospheric pressure is not going to change my calculation. I'm interested to find out what is the impact of pressure due to the liquid's height or the liquid's depth, as we call depth. No, depth. As the liquid's height or liquid's depth. Have you understood? At the top level, the pressure contributed by the liquid will be how much? 0. There is no pressure, right? As you go down, so let's say P1 due to the liquid will be equal to 0. There is no pressure at this surface. If I go down here, I have a pressure P2 due to the liquid. I have a pressure P3 due to the liquid, and I have a pressure P4 due to the liquid. Have you understood? आप दिमाग लगाइए. When you are at P2, how much of water is above you? Let's say you just try to stand here with your head out here. Imagine on your head, how much of water is there above your head? This much. They will contribute to some force. Agreed. Now we bring Abhigya and we ask her, Bittu, tum na yahan khade ho jao. Don't you think Abhigya's head is now sensing much more force? Because it was this much water plus this much column of water. And let us take Ryan at last and bring him out here. What do you think? He is sensing the maximum amount of force. Is the surface area changing? No, the surface area is nothing but the area of a circle, because this is like a tumbler. Area of the circle. Is the area of the circle changing anywhere? No, the area is constant. What is increasing? The force is increasing. Do you agree? Here there was no force. Let me complete once. There was no force due to liquid. What was there? Only atmospheric pressure. Here there is a force. No, we'll come to pressure later. So there is a force due to the liquid column. Here there is a force which is a little bit much more than the liquid column. And here there is the maximum force. So if I now try to compare them, I will write my P1 was the least, which was almost 0. And these are all due to the liquids, okay? And then I came to P2, then I came to P3, and at P4, I am sensing the maximum pressure due to the liquid, right? And if somebody tells me, what is the total pressure at every level? Well, you also add the atmospheric pressure. Now the atmospheric pressure is constant. So we do not consider, it is not going to change the game. Game will be changed by what? How much of liquid column is above your head. So what do we sense from here? As we go down the depth, pressure increases. So this is a very nice finding that we found. We say pressure increases with depth. Okay. Yes, Ran, you were saying something.
There's some amount of water putting force on the person.
See, for pressure to come, I am trying to find out the pressure at each level. What is pressure? Force per unit area. Area is the area of the cross section. Cross section, do you understand cross section? The drums, every level of the drum is a circle. So, who is contributing to the pressure? The water column above you. At the first cross section, do you have any water column above you? No. So, you don't have any liquid pressure. All pressure you are sensing, here P1 is equal to 0. The entire pressure is contributed only by the atmospheric pressure. At P2, this much of liquid column is putting weight on you. You sense some pressure. But when you come to P3, this much height of liquid column is causing pressure on you, force on you. So don't you think the pressure is more as you are going down? Now that is one of the reason, you know, dams are what? Dams are walls built by men to store water. Or do you know the piers of bridges? Like you must be piers. Do you know what are piers? You must be going through now Gachibowli crossing every time. So when the flyover is made, don't you see those towers first being constructed, the metro, the pillars, which we call it. They're known as the piers, okay? So when you have those pillars being made for railway bridges over what? Over sea or over rivers. Don't think, how do you see the pier? Now, if you see a metro rail pier will be something like straight pier because it is on land. Do you agree? But if you go to a sea bridge, railway bridge, you might be seeing it straight. But my dear child, it's not straight at the bottom. They are made broad at the bottom. Because the pressure at the bottom is much, much more. Similarly, how does a dam wall look to you? The dam's wall is like this. What you see as a dam with your naked eye is only this much portion. Therefore, you feel that the dam is having a wall. Lekin niche ke walls kaise hain? The dams of this question comes to you. Why are dam walls made thicker at the bottom? The dam walls are made thicker at the bottom because as we go down, the pressure increases. Yes. When pillars, yeah. So what we do, that's very nice. You should then go to YouTube and see how bridges. Now in India is going to have two major constructions. See, many people nowadays, that's such a nice question. People only talk about IT. Civil engineering is called the marvel of engineering. Today we are standing on what? 13th floor. Do you ever have a fear that your building will collapse? No. Babies are being brought up in this floor. When an aeroplane touches the runway, do you ever think that the wheels will break? No. Who gives you that guarantee? That is the engineering's beauty. So now India is going to have two bridges that are coming up. One bridge is coming up over Brahmaputra. One bridge is coming up on Rameshwaram. Okay. These are marvels of the world. So when those are made, you will actually have a lot of flushing action happening and columns are put inside. Till you reach the bed, it takes a lot of time. How much of calculation, how much of stiff work, and then it happens. Let's look at your balcony. Your balcony is something without a support. Every day you go and sit there. Do you have a fear that it will break? Doesn't it?
So whenever we go swimming or whenever we go to the water, or like at beaches, even deeper in the beaches, we always float on the top of the water.
You'll always float on the top of the water because the water, that you in grade 9 you'll study something called buoyant force. Whenever you put your hand inside water, something pushes your hand back. So whenever you submerge something partially, you take a Coca-Cola bottle, empty, cork it up, and then try to submerge it, it will not go. Or you take your swimming that flap and you try to put it inside, it will never go. So they say, sir, yeah.
That's what we are learning now.
Yeah. So we say we are very, sir, I am very heavy or I am fat. I am afraid of swimming. The more fatter you are, the better for you to swim. Because more is your weight, more will water will cause buoyant force on you. आप और तैरोगे ऊपर में. But यहाँ हमें जो चीज सीखना है, some interesting things. Now, the first interesting thing from your course perspective, pressure increases with depth. As we go down, the pressure increases. That's why the walls of dams are made thicker at the bottom. So the question that will come to you is, why are walls of the dam made thicker at the bottom? Walls of dams are made thicker at the bottom in order to take care of the pressure that builds up at the bottom, and pressure increases with depth. Now suppose this bucket which I made, I do some styling on this bucket. What styling I'm doing? I have some corks out here, orifice, and they are plugged corks. Okay, you know cork? Just like that homeopathy bottle medicines corks, the corks are there. And I ask Anay that take your hands, two of you, because you have two hands only, open up all the corks at the same time. No, you can open up all the corks at the same time. You will find that the water might just fall here. Here the water will fall like this, here, and here the water will go the maximum. Why? Because the pressure is maximum at the bottom orifice.
So then you put small hole.
Yeah, I have made holes and I have put corks on them. Now I have filled it up. My theory tells me that pressure increases with depth. Now I want a practical explanation. So I called two of you and I said, have you held the corks? Yes. At the count of 3, 1, 2, 3, open the corks. So if you open the cork, you will find that it will just come out it will just fall and maybe along the surface. There's no pressure. But as you come to the bottommost part, the pressure is maximum. In fact, if we were getting water without pumps and we are storing water on 19th floor, the ground floor, if you open, see, how is the water supply regulated in a housing apartment? The next question comes, sir, the tank in the housing apartment is on the 19th floor out here in Pebble City. This is 19th floor. This is ground floor. 19th floor should not get any water pressure at all. Do you agree? He should be suffering while having shower. Whereas, no, there will not be hardly anything, just little bit. Whereas if think about the ground floor, think about Sharvesh at second floor. The moment he opens his tap, he should be blown away. So what we do here, we have got a pump which regulates and creates equal pressure at all floor. Therefore, every floor you go and open the tap, you see the same pressure. If you were actually seeing pink buildings and all, they don't have such pump system. There, how does the water come? By gravity. So the tank is on top of the second floor. Person on the ground floor will always get water with more force because his depth is more. So the pressure is more. But in our case of condominiums and all, where we have how many? 19 floors, you can't expect that. Otherwise, these floors will get very less pressure. And this fellow, by the moment he opens, बच्चा छोटा infant baby को नहलाने ले गया, मम्मी खाली ऐसा कर रहा है, बच्चा तो चला गया already. Are you understanding? Okay, now some more interesting thing. You have heard about the ship called Titanic? Titanic lies 11.4 kilometers below the Atlantic. Okay, yeah, Mariana Trench. Okay, so it's like it's 11.4 kilometers. We can't go as humans to the Titanic. Why? Because a submarine can maximum go 500 meters down. After 500 meters, the pressure builds up so much that you need very good quality steel. Otherwise, the entire submarine will be ripped apart. If we as human beings go down below, we cannot withstand that pressure. That's what is known as implosion, not explosion. You won't explode. Pressure will crumble and break your ribcage and other bones. Have you understood? So a submarine cannot go as much as it wants. 500 meters, uske baad submarine will want to come up. It can feel the pressure. There was an accident 2 years back when they went, the commercial submarine, they wanted to go and visit the Titanic. Okay, there are some robo submarines which go and take pictures of Titanic. Do you know the thickness of their viewing window, the glass? You know what is the thickness? 40 inches. This is a 12-inch scale. This scale is 12 inch. 40 inches is the thickness. और आपका इंसान का बोन कितना है? वो ऐसे ही सूप बना के तोड़ देगा उसको, कटराक. So these deep sea marine animals like whale and others, they can bear that pressure. We can't bear that pressure. समझ में आया? We can go down to a level only. After going down too much down, we human beings cannot survive. Pressure increases with depth. Is this clear now? Pressure increases with depth. जितना नीचे जाएंगे उतना water pressure ज़्यादा है. Have you understood? उतना water pressure ज़्यादा है. And that's why some children asked me the other day that there is an equation you will study in higher classes. We say pressure is equal to rho gh. What does rho? This is very high level for you. H stands for the height. G stands for gravity. I mean, leave it. Why to unnecessarily break your head? हाँ, तो ये यही बताता है आप जितने हाइट के नीचे जाएंगे, हाइट कहाँ? मान लो ये सारी बातें हो रही है, यू आर इनसाइड लिक्विड. लिक्विड में आप हाइट तो नहीं बोल सकते हैं. डेप्थ. व्हाट इज द डिफरेंस बिटवीन हाइट एंड डेप्थ? Anything that is seen from the ground level on top is called height, whereas your coffin is always having a depth. Have you understood? Depth is anything below the ground level. Height is anything which is I bring a what you call a container for Nike, and I can say what is the depth of the container, and I can also say what is the height of the container. Height is anything when you see. So what we say, as you go down, as the height increases or as the depth increases, your height, liquid column's height considering your head, or your depth considering the liquid column, the more deeper you are, the more pressure is being exerted on you. समझ में आया? So in liquid, what all question we can get? True or false? As height increases, pressure increases. Means as depth increases, pressure increases. Don't use the word height, use the word depth. As you go down, and some of the implications are dams of the walls of dam as well as of piers are made thicker at the bottom. That's why a submarine cannot go as much as it wants. ऐसा नहीं कि submarine goes on going below. A submarine can go only up to 500-600 meters. उससे नीचे जाएगा, क्रैक करके टूट जाएगा. We are almost coming up now. Once the chapter finishes, I will give you chapter notes. Then I'll give you some assignments also to do. Don't worry. But you should understand them, because when we do revision, we'll not go that deep. Clear? Time for us to now move to gas pressure. Clear? Okay. Pressure in gases. Pressure in gases. So solids exert pressure. In that, we are almost interested to always know what is the surface area. Liquid, we are interested to know what? We are interested to know what is the depth. So pressure in gases. So gases also exert pressure. Exert pressure. So a little bit of understanding of what is gas pressure, right? What is gas pressure? So let's say I have a balloon, and in this balloon you have filled what? Air. Is air a gas? Yes, air is a gas. So the air particles, we can't see them. They are exerting pressure on the walls of this balloon. Do you agree or not? As a result, the balloon, you just can't compress the balloon. आप जैसे compress करते हैं तो लगता है अंदर से भी कोई आपको धकेल रहा है, right? What is that? That is the compressed air which you have blown inside. So gases exert pressure. A little bit of understanding. What does pressure in gases actually mean? So let's say I have something which is known as a piston. Piston means something like this, where you know what is like a cycle's air pump. This thing can go inside and go out. Piston. This thing can go inside and go out. Let's say we have put air inside it now. Okay, air is there. So what is air? We have got air particles or air molecules. So these are known as my what? Gas molecules. This story you will be listening till grade 12. Gas molecules. Okay. These gas molecules are like you kids with no teacher in the class. That means you all become what? You all try to prove that man was born from apes and monkeys. So you all prove that in class. These molecules are always in motion. They are always in motion. And they are in motion. So this motion is something like of naughtiness, or you can say disturbance. This motion is much more in the case of gases. In the case of liquid, it's less. Solids are the most disciplined kids. Solids have motion, but very less. They are always in motion, continuously in motion. Yeah, and they are loosely packed and all. So how do I show them? I say, and this motion is random. This fellow is going this way, this fellow is going this way, this fellow is going this way, this fellow is going this way. यार ऐसे जाते जाते रह रहा है. समझ में आया? अब हम क्या करते हैं? Always in motion. So when anything is in motion, it should have energy. So we say that form of energy is known as kinetic energy. Kinetic energy is any body, whichever it is in motion. And if you say this boy, any time he's running around, so he has a lot of energy. What energy? Kinetic energy. Muscular energy is getting converted to kinetic energy. This boy, always he sleeps, he's at rest, he has no kinetic energy. Kinetic energy means energy due to which a body comes in motion. So if you are in motion, you have kinetic energy. Okay, have you understood? Kinetic. Oh, I didn't see that. K-E-N-E. Thank you. Kinetic. Okay. It has kinetic energy. Understood? Now, gas molecules have got kinetic energy. As a result of this, what they are doing, they are in motion. And due to motion, what they do, they collide with walls of container. Walls of container. Have you understood? That container can be the balloon's walls also. That container can be piston. Now, when you have these collisions and when they are colliding, these collisions are very rapid collisions. अब कैसा हो रहा है? Imagine that this is a gas molecule and imagine my cheek as the wall container. You might be thinking the molecule comes, tuck, ऐसे collide किया, ऐसे collide किया. Then I can say, what do I say? Don't poke me. Don't poke me. If I increase its speed, don't irritate me. Have you understood? Now it's so fast that I can't see the finger. When you were a kid, I don't know if any elder has played that game with you. We used to do मछली पकड़ो. जैसे ही आप पकड़ते थे ऐसे you caught a frog. Yeah, how many blades are there in this fan right now? No, 3 you know. If you would have seen it, right, you can't guess. 3 blades. 3 blades you said? Put your hand inside. Put your hand inside. Why are you afraid? But it's going at a rapid speed. That means at every time, every place, there is 1 blade. Do you agree? So imagine my fingers are so fastly hitting on my cheek now, which are molecules, that you don't see these fingers at all. It was poke to irritation, and now it has become pain. That pain is nothing but the continuous force over the area which is causing the pressure. समझ में आया? यही अगर हम solids लेके आते, suppose we bought mangoes in a carry bag, the mango will exert the force only on the bottom portion of the bag. The liquid will exert on all sides. Whereas if you bring gas in a balloon, if I suppose you're carrying a carry bag full of mangoes and I take some needle and I keep on puncturing the top surface of the bag, how does it bother you? Not at all. But if you bring a balloon and I puncture at any place, the balloon bursts. That means pressure is exerted in all directions. And how is pressure exerted? Every gas has got molecules. Molecules are in continuous motion. and this motion is due to their kinetic energy, due to which they strike against the walls of the container with very frequent collisions. And these frequent collision, this frequent collision is actually causing that pressure. Now use your common sense. You start heating this gas. If you heat this gas, are you not giving it more heat energy? Yes. More heat energy means that heat energy will be converted to kinetic energy. They'll be moving even more faster. So more pressure, a hot gas exerts much more pressure, right? And suppose now what you do, cycle में जब आप हवा देते हो, first you pull it up, means you pulled it this side, all the air gone inside, then you are reducing the area. So pss करके निकलता है, pressure increases. That's why it's called a hand compressor, na? I suck air, I compress the air, then only it will get inside my tires.
With air, you said all the molecules move in a random motion.
Random motion.
So you can't actually say that they're moving in all directions.
They're moving in all direction. There are so many molecules. There are so many molecules. Okay, let me give you a small example. Suppose I bring 50 naughty children from your class and put them in that small room of mine. You mean to say that only one side of my neighbors will make a complaint?
They won't even be alive into
No, we'll give them that much space. My left neighbor will also make a complaint. Maybe that tower also, pressure will be exerted in all directions. Yes or no? Agreed. So this, or think about a chicken farm. You have so many chickens. They run around all sides. Those chickens you can see with your eyes. Here you can't see. Yes, sir. Yeah. Yeah.
So you were saying they send hot like submarines down to take pictures of the Titanic. How thick would the interior be so that it
That is done with the quality. That's called the metallurgy. That quality of the material with which they build is extremely costly. You can just Google that how many, the richest man of Pakistan and his son also died in that accident which happened 2 years back. It's almost 2 years now. So today you go home and try to Google the, it's called the implosion. It's not called explosion, it's called implosion. There was a firm in America. So they sold tickets. So 5 or 6 people bought those tickets, all were billionaires, wanted to go down because it's very costly. That vessel is built very costly. Imagine you boiling potatoes in pressure cooker. Have you seen pressure cooker wall? The pressure cooker is a very costly device. Your frying pan is not that costly because the pressure cooker handles huge amount of pressure. And do you know, children, have you seen how a pressure cooker is locked? It's locked with a buckle, right? And after the potatoes have boiled, if you take it out from gas, that's why I say your kitchen is your best laboratory. If you take it out from the gas stove, the pressure cooker won't open immediately. Why it won't open? Andar pressure bhara hua hai. So first you have to release the pressure. That's why what your cook or mom does, they have to release the pressure. Only after that the pressure cooker will open, because you are trying to open with the force from the top. वो तो अंदर से पूरा pressure में है. A pressure cooker is equivalent to a bomb. So never buy cheap quality pressure cookers, because if it putrefies, you're gone. So you should always buy good quality, certified quality pressure cooker, what you call as ISI. ISI mark good quality. Yeah, tell me.
In pressure cookers, when they like blow the whistle around, what is that liquid that comes out bubbly around?
Yeah, that's the liquid what you're boiling inside. So part of the liquid has been converted into vapor, right? And that vapor is now causing pressure. So what you do when you release the whistle, or you release the top lock, when it just release it, then you are allowing the pressure to come out. The vapor is released. As a result, the pressure inside the pressure cooker reduces, and at that time you can open. Did you know this fact? Pressure cookers gas se utarne ke immediately you can't open it. You cannot. No matter how much you try, you cannot open it. Have you understood what causes gas pressure? So pressure of gases can be increased by either reducing the area, or what you can do, or increasing the temperature. Heat a gas, more will be the pressure. Thick. No, surface area we can't increase, because overnight our pressure cooker can't become Motu. How do you expect that? Piston में भी surface area मतलब आप इसमें cross section area बढ़ा दीजिए, then you are reducing the pressure. आराम से आएगा, है ना? Yeah.
Necessarily, what about bombs?
What kind of
That is a different, that is a chemical reaction which gives you a lot of energy. A bomb is a chemical explosion which will give you a lot of sound and lot of light, as well as enormous amount of chemical energy is released. And that release of energy is done with, a lot of particles which actually cause destruction, warheads and missiles and all. So a lot of heat will be involved. Okay, have you understood pressure in gases? Now what we need to understand in pressure in gases more interestingly for our chapter is atmospheric pressure. Atmospheric pressure. Okay. Note down this device. The atmospheric pressure is measured by a device called barometer. Okay. Barometer. Now, what is the atmospheric pressure? Let us understand. So, we have got a lovely little planet where we stay, which is called Earth, and up to say 5,000 odd kilometers all. Okay, 5,000, yeah, 5,000, roughly 5,000 kilometers. We have a thin layer of air which is known as the atmosphere. So it's quite thin as compared to the space and all. Okay. So what does this atmosphere do? This atmosphere contains gases. And what all gases will it have? It will have a lot of nitrogen. Nitrogen is the maximum. Okay. Followed by it will have some part of carbon dioxide. It will also have oxygen in it. It will have dust, right? And ozone also. Okay. Ozone is not in the atmosphere. Ozone is beyond. Ozone, it's like a layer, but that's very less. We can say argon also. So these are the gases which are present there. Have you understood? This atmosphere also creates a pressure on the earth, and that is known as the atmospheric pressure. Now let's make our diagram a little bit more interesting. So let's say this is the surface of the earth, and a person is standing on the surface of the earth, right? This is earth. Now, who causes atmospheric pressure? Atmosphere causes atmospheric pressure. What is the atmosphere comprising of? Gases. In other words, I'll call it as air. Air is a mixture of gases. So it is air which is causing you the pressure. So what happens on the head of this person? There is a column of air. There's a column of air which is actually causing the pressure on this. Now start thinking in your geography knowledge, what happens to the thickness of air as we go up? As we go up, air becomes lighter and lighter. Why? Because the earth is pulling the air particles towards itself. Earth's pull for this fellow will be more than this fellow. So I'm making some drawing. Just tell me, let me know. These are air particles. Don't I expect more air particles here? Here a little bit thinner. Here more thinner. Yes or no? This is quite a height. Okay. Have you understood? Atmospheric pressure is caused by the atmosphere. What does the atmosphere comprise of? Gases, predominantly air. So air is comprised of air particles. So this fellow on his head is now sensing what is known as atmospheric pressure. Who are the contributors? These air particles. Now let us look at the air particles as we gain height, as we start gaining height. So Earth's gravitational pull is pulling these. So the atmosphere is thicker at the bottom, thinner as we go up. So we will have less air particles here, more air particles here, lesser, lesser, lesser. Do you agree? Who is causing the air pressure? The particles are causing the air pressure. 1 minute. The particles are causing the air pressure. If the particles itself are reducing, do you expect pressure to arise? No. So we will find, let's say we create 3 levels, say PA1, PA2 and PA3. We will find that the pressure PA1 is much more than the pressure PA2, than the pressure PA3. Have you understood this logic? As height increases, atmospheric pressure reduces. Why? Atmospheric pressure is caused by the atmosphere. So let's write it down. Atmospheric pressure is caused by whom? Atmosphere. What do you have in the atmosphere? Air. What is air? Air particles. Yes or no? This is the storyline. Now, as you go up, you have more air particles, less air particles, least air particles. Do you agree? Therefore, the pressure is more, the pressure is less, and the pressure is least, very opposite to liquid. That means if I am on the sea surface, the pressure I sense due to the water is minimum. As I go down the sea, the pressure increases. But as I fly up from the sea, I go up to a mountain. In mountain, the air pressure will be much, much less. Yes.
The top of the mountains, it's so cold, but mountains at the tip are closer to the sun.
Mountains at the tip are closer to the sun. That's a different story. That we will tell you. As of now, that temperature will cover all these things. What happens? How much of carbon dioxide there? Yeah.
This is the reason why our ears pop.
Yeah, ears pop and all will come to this. So the air pressure, have you understood what happens as height increases, the pressure falls down. Now, couple of examples. Okay. You must have seen all those Lay's and other chips packet. Right? They are always pressurized from inside. They are packed with nitrogen gas. Right? So take one reel of Lay's chips with you and go up to a mountain range. Let's say you have gone to Ladakh. Slowly you will observe that all your Ruffles, Lay's and all these chips packet have become almost, you बड़े बड़े हो गए हैं. क्यों बड़े हो गए हैं? अब आप सोचो. When they are at your house, they have nitrogen pressure which is acting on their packet. Do you agree? And they are also being acted upon by atmospheric pressure. Atmospheric pressure is quite high. What is on our head right now? 1 atmosphere pressure. If you increase this 1 atmosphere to 2 atmosphere, just to give you an idea, this bone will immediately rupture. This bone will immediately rupture. Fracture नहीं, rupture हो जाएगा. आपका सर टुकड़ा हो जाएगा. So can you understand what is 1 atmosphere pressure? So these packets which are filled with nitrogen, अंदर से क्या बोल रहे हैं? हम नाइट्रोजन हैं. बाहर से atmospheric pressure, चुप, they are also there. So the packet has got a typical shape. Now, when you have taken this to say Ladakh, he starts saying, हम नाइट्रोजन हैं, लेकिन बाहर कोई टीचर नहीं है. When we have gone to Ladakh, then what happens? These have got reduced drastically. So who is the king now? The nitrogen is the king now. That's why as a traveler also you should have, we should use common sense. Many idiots, what they do, they'll carry a lot of chips in their car. And as they're climbing height, these chips packets will burst. Tham ठूप करके फटना शुरू करेगा. और फटते ही बोलेगा पता नहीं गाड़ी गंदा हो गया. Now another nice scene. Let's now take our friend. अभी हम श्रेयस को ले चलते हैं. कहाँ? शिमला में ले चलो. ये श्रेयस है. This is Shreyas. Okay, inside his body, what is the liquid that is flowing? Blood is flowing. Yes or no? Through all the veins. So let us see his blood vessel. So his blood vessel is something like this. Through this blood vessel, what is going? Blood is flowing. Arey yaar. Okay, this is his blood vessel. And through this blood vessel, blood is flowing. Do you agree? This blood is always exerting, it's a liquid, so it is exerting pressure on the wall. That for senior people we say blood pressure. आपका BP बढ़ गया है, blood pressure. If this pressure is too much, what is the fear? This blood vessel might rupture. When we take a blade and we get a cut, what happens? This blood vessel, there are many blood vessels in our body. So these blood vessels get a cut. If the cut comes out, the blood comes out. Do you agree? Now, when Shreyas is at Hyderabad, then he should have a blood pressure in his body. So the blood pressure is inside and it is being balanced by atmospheric pressure. There is atmospheric pressure which is acting on his body. Now we have taken him where? To Ladakh. As he goes to Ladakh, suppose his blood pressure normally is little bit, थोड़ा high pressure है इसको, tension में रहता है. He's got more blood pressure and the atmospheric pressure has reduced. Now what will happen? Nose bleeding will start. जहां से मिलेगा वहीं से निकलेगा. You hear that in mountains people suffer from nose bleeding, ear bleeding. These happen. Rupture होना शुरू होगा. In fact, what you think when an aircraft goes up, now you should ask what happens in an aircraft. So whenever the ears pop up, बात की बात है. Whenever the aircraft goes up and it is taken up, it is still like this. Means the air hostess crew and all are seated. The flight is still like this. The first job of the first officer is to pressurize the cabin. The cabin is always pressurized. Cabin is always pressurized. Aircraft has to be pressurized. If they don't pressurize the aircraft, Then after 2-3 minutes, you will nauseate. And what will happen? The oxygen mask will get deployed. And that has oxygen for only 2 to 3 minutes. This happened in a Jet Airways flight few years back from Mumbai to Delhi. They've forgotten to pressurize. So if you don't pressurize, after sometimes 1 or 2 passengers will immediately have ear bleeding to start. That's why if you open the door of an aircraft while it is flying and you are not belted, you will just fly out. The aircraft is fully pressurized. It's like a pressure cooker. And then when you land, it is also depressurized. If that job is not done properly, that's when you sometimes say, "Aaj pata nahi takeoff ke time na thoda ulti, thoda dizziness." You have that feeling. Sometimes every takeoff and every landing is not as smooth as you think. In bigger aircrafts, we don't feel it. In smaller aircraft, sometimes you'll say, "Thoda giddiness jaisa ho gaya." Just sometimes they'll say, "In a short while from now, we will be landing. Please stow your tray tables, make your seats straight." That is the time when the pressure balancing is done. If that doesn't happen properly, aapko, maybe you'll just sleep at that time. Some inaction will happen. So air pressure is very important. Have you understood what happens with air pressure? Please remember that atmospheric pressure decreases with increase in height. As the height goes up, and one of the reasons for this is vegetables not boiling properly at height. That you will not understand now. आलू जो है ना, ऊपर उबालने में ज्यादा मुश्किल है, ऊपर प्रेशर नहीं रहता है. तो प्रेशर आने के लिए आपको अब जैसे ही हाइट में चले जाओगे, एटमॉस्फेरिक प्रेशर फेल करेगा. दैट्स व्हाई ब्रीदिंग बिकम्स डिफिकल्ट. सो व्हेन यू गो टू लद्दाख एंड ऑल, दे विल नॉट टेक यू फॉर साइट सीइंग ऑन द सेम डे. आपको एक दिन रख देंगे जस्ट टू एक्लिमेटाइज. दे विल नॉट आस्क यू. एंड इफ यू गो टू वेरी हाई, like say you're going to China and all, and in Tibet areas, there you will not be even allowed to have shower and all for 1 or 2 days. Body acclimatization is very important. थोड़ा सा चलने ही से ही आपका ऐसे हो जाओगे. Yeah, atmospheric pressure does not decrease. Atmospheric pressure decreases with increase. Altitude and height are same. Altitude and height are same. जैसे जैसे आप नीचे आओगे, प्रेशर बढ़ेगा फिर से. So that Ruffles lace packet, which became a big balloon, when he again comes back from Ladakh to Delhi, that Ruffles lace packet, there's no leakage. That packet again settles down. Yeah, tiny not deflates. What has happened? Decreases. इसीलिए तो कहते हैं, see what happens. The blood pressure is always more than the atmospheric pressure. That's why if I make a cut on your body, what comes out? Blood comes out. Means the blood pressure is eager, much more than the atmospheric pressure. Then only the blood will come out. जो आदमी मरा हुआ रहता है ना, dead man's heart is beating? No. So dead man's blood pressure has actually gone 0. If you cut the body of a dead man, blood नहीं निकलेगा, मतलब फ्लो होके नहीं निकलेगा, क्योंकि अंदर प्रेशर नहीं है ना. समझ में आ रहा है?
But it's a liquid, so
हाँ, थोड़ा सा ग्रेविटी के लिए निकलेगा. और आपका जैसे कट्टे ची करके आना शुरू हो जाता है ना, वो नहीं होगा. Like in movies where there are all these war movies and scenes they show, na, with a sword they have cut, and nowadays they show it too much, blood just comes out. Dead man का वो नहीं होगा. Clear? And all those questions and all that we have. So we come to the end of this chapter. Now what I would request you is that I will pass on notes. No, that's not an issue. Please read the Lakshmi Singh textbook, at least the bold lines properly. After that, you can answer questions from there. I'll give you a worksheet also. Now, this worksheet will be a combo worksheet, which will have everything, right? And you can take your time. I'll give you time for submission. Also, what you are the only one who did not submit a worksheet. Where did you submit? Everyone has submitted. You didn't submit. I will not say. My job is not to follow up, okay? And I'll give you notes. And if you have the exam idea book, read from there also, see the important questions. It's not only about gaining knowledge, we should also be gaining knowledge to answer properly. And to answer properly, wordings are very important. So both you girls, as I told you last time, pay attention on the book's language, read from that textbook. That textbook is very beautifully written, at least the bold words which are there. And should you believe that there is something in your textbook that I did not cover, please feel free to tell me, and that you can tell me only when you read everything and come. So have you understood what happens in case of liquid? Pressure increases with depth. In case of gases, how is the pressure exerted? Due to the gas molecules. And in case of atmospheric pressure, as you go up, the atmospheric pressure falls down. And there is, okay, there will need one more class, some applications of atmospheric pressure. Like how do you, we can do it immediately right now. Okay, now how do you drink lassi with a straw? So there's a straw out here, and this is our friend Shreyash. Now he is saying, "Prak karke pee raha hai lassi." So what he does, he is sucking out the air from the straw. Understand? This is his lassi. He is sucking out the air from the straw. So what is the pressure inside the straw? Less. Atmospheric pressure is acting on the lassi. Also dabata hai, मुंह में चला गया इसका. Number one example. Number two example, filling something with a dropper. Have you seen dropper? The droppers that we use. Okay. Now when you squeeze the dropper, what happens? You expel all the air from the dropper's capillary. So pressure inside the dropper has become almost zero. और जैसे इसको और उस पर क्या देखो, एटमॉस्फेरिक प्रेशर को तो आप रोक नहीं सकते हो ना, वो तो लगा हुआ है. और जैसे ही आप ड्रॉपर को छोड़ देते हो, एटमॉस्फेरिक प्रेशर बोलते जाओ ट्वीन करके ऐसे आ गया. Then have you seen those mobile what you call what we call the stick-on rubber stickers with the mobile holders in cars on the that we have. तो उसमें not the magnet one, the ones which you just stick on the glass and then you lock it. So mobile holders in car, no magnet वाला नहीं. Have you not seen rubber stick-ons जो बाथरूम में भी आजकल लोग लगाते हैं, ऐसा टपक करके चिपक जाता है. Hey, you must have seen. Advait, have you seen or not? The suction stickers that I'm talking about, which all Uber cabs will be having hanging on there. So how does the suction sticker work? The suction pad is something like a curve. So it is made to first forced in such a manner. So this is my wall or the glass surface. The suction sticker is first in what shape? It's like this. There's a lot of air inside. So what they will first do, they will first isko dabaega in such a way that it will bring it along the surface, expel all the air out. And then there will be a lock pin. They will just lock it. All air out. What happens? Atmospheric pressure will be acting on it and it holds this suction gun. Therefore, they say, before putting a suction sticker on your car's front pane, ensure that the surface is properly cleaned. Now, if there was, now say our friend Ryan, he is very dirty with his car and he has got some dust out here. The dust will create what? Space. No space. और जैसे space create करेगा, who will get inside? Air will get inside. And as soon as the air gets inside, the air will say, oh darling, just becomes, and then his mobile, his costly phone, धपड़क करके नीचे गिर जाएगा. Many people now use toothbrush hangers and other things also. They don't drill holes. They just stick on rubber stickers.
I see like in someone's car, they put that phone holder,
Right.
but it came off. To fix that, they took it to a shop, but the shopkeeper, what they put glue on it.
So that's, see what happens another way. Since you stay in Dubai and other places, they're hot places. So in summers, what happens, if the quality of the rubber is not good, rubber is prone to heat damage. So as it gets warmer and warmer or hot and hot, this rubber also expands. Like when I bought this t-shirt, don't you think the collar was absolutely a circle? Every day by entering my head, which is like a pumpkin, this is also no more a circle. There will be uneven shape on it. That uneven shape gets created, and whenever there is an uneven shape, what will happen? Air will get in. You know what I did? My car also faces a lot of heat. So what I did, this is my rubber sticker. Advait, this is for you. So this is my rubber sticker. Right at the center, I put one 3M tape circular patch. I also did the same thing. And now I have stuck it. And now it's more than year, 2 year. My dash cams and all are absolutely properly stuck on the car. Okay, so that is a magnetic one. So this one, it holds very properly. So these are examples of atmospheric pressure being used to. How do you drink with a straw? When we suck with a straw, we take away all the air, pressure reduces, atmospheric pressure pushes the lassi into the straw. When we squeeze the rubber on the dropper, the air goes out, there is no pressure, atmospheric pressure pushes it inside. Rubber sticker, When you actually push it against the surface, you take all the air outside and then you lock it. So all the pressure is there, it is from outside. So they hold it. As simple as that. Another way, like you do, take your hand. Like, have you played Hanuman in your childhood days? We used to take a katora, put on our mouth, and
Yeah.
so what you are doing, you're sucking the air inside. You're sucking the air inside. So who is winning? Outside atmospheric pressure. That is putting the bowl stuck to my mouth. That concludes our class, right? So